Before we dive in, make sure to like this video, subscribe to the channel, and turn on the notification bell so you never miss a new upload. And after you subscribe, let me know in the comments what video ideas you'd like to see next. Imagine this. You're floating in space, drifting silently through the darkness. Stars glow in the distance, galaxies stretch across the sky like cosmic clouds, and ahead of you is something that shouldn't exist, a region of pure darkness where the universe seems to disappear. No light reflects from it, no detail can be seen. Just a perfectly black circle against the stars, a black hole. Now imagine that instead of turning away, you keep moving closer. What actually happens the moment you fall into a black hole? For a long time, black holes sounded like science fiction. Invisible monsters in space that swallow everything. But today we know they are very real. Astronomers have even photographed one for the first time in 2019 and later captured the black hole at the center of our galaxy. These objects form when massive stars collapse under their own gravity, squeezing enormous amounts of mass into an incredibly tiny region. The result is gravity so powerful that nothing can escape once it gets too close, not even light. The boundary around a black hole is called the event horizon. This is often described as the point of no return. Cross this invisible line, and escape becomes impossible. But what actually happens when you approach it? Would you be instantly destroyed? Would you feel it? Would the universe suddenly go dark? Let's start far away from the black hole, where its gravity still behaves like any other massive object. From a distance, a black hole isn't some cosmic vacuum cleaner pulling everything in. If our sun were magically replaced by a black hole with the same mass, Earth would actually continue orbiting almost exactly the same way. The difference is that the black hole would be much smaller and completely dark. But as you travel closer, things begin to get strange. The first thing you would notice is how the stars behind the black hole start to distort. Gravity bends space itself, and light follows those curves. This effect is called gravitational lensing. The black hole acts like a giant cosmic funhouse mirror. Stars that should be hidden behind it suddenly appear around its edges. The sky stretches and warps into glowing rings of light. If you looked straight at the black hole, you wouldn't just see darkness, you would see the entire universe bent around it. As you continue drifting closer, time itself begins to behave differently. According to Einstein's theory of general relativity, strong gravity slows down time. The closer you get to the black hole, the slower time moves for you relative to the rest of the universe. Imagine a friend watching you from a safe distance with a telescope. From their perspective, you begin moving slower and slower as you approach the event horizon. Your movements stretch out, almost like a video being played in slow motion. The light from your body becomes redder and dimmer as it struggles to escape the black hole's gravity. To your friend, something strange happens. They never actually see you cross the event horizon. Instead, you appear to freeze just outside it, fading away over time until your light disappears completely. But your experience would be completely different. From your point of view, time feels perfectly normal. Your watch ticks at its usual pace. Your heartbeat doesn't slow down. You continue falling toward the black hole, unaware that the outside universe sees something very different. Now the real danger begins. As you get closer to the black hole, the difference in gravity between your head and your feet becomes enormous. The part of your body closer to the black hole feels a stronger gravitational pull than the part farther away. This difference is called a tidal force. On Earth, tidal forces are what cause ocean tides because the moon pulls slightly harder on the side of Earth closest to it. But near a black hole, these forces become unimaginably extreme. If you fell toward a smaller black hole, the tidal forces near the event horizon would stretch you violently. Your feet would be pulled much harder than your head. Your body would begin to stretch longer and thinner as gravity pulls you apart. Scientists actually have a name for this process. It's called spaghettification. You would literally be stretched into something resembling a long strand of spaghetti. Your bones would separate, your organs would stretch, and eventually the atoms in your body would be pulled apart. It's not a pleasant way to go. But here's where things get even stranger. If the black hole were extremely massive, millions or billions of times heavier than the sun, the tidal forces at the event horizon could actually be surprisingly gentle. In that case, you might cross the event horizon without immediately noticing anything dramatic. No flashing lights, no cosmic explosion, no sudden wall. You would simply pass the point of no return. And that is where the universe becomes truly mysterious. Once you cross the event horizon, escape becomes impossible because space itself is falling inward faster than the speed of light. Even if you fired rockets at full power, you couldn't move outward. It would be like trying to swim upstream in a river flowing faster than any swimmer could possibly go. But it's even more extreme than that. Inside the event horizon, the direction toward the center of the black hole becomes as unavoidable as moving toward the future. Just like you cannot stop time from moving forward, you cannot stop yourself from moving toward the singularity. The singularity is the heart of the black hole. According to our current understanding, it is a point where density becomes infinite and the laws of physics break down. Gravity becomes infinitely strong, and space and time curve beyond anything we can describe. But the truth is, we don't actually know what happens there. Our best theories simply stop working. Some physicists believe the singularity might not truly be a point, but something far more complex. Others think quantum effects could prevent infinite density from forming at all. There are even ideas suggesting that black holes could connect to other regions of the universe, or perhaps even other universes entirely. Right now, we simply don't know. But your journey inward continues. As you fall deeper inside the black hole, the outside universe would appear to speed up dramatically, because time for you is slowed relative to the outside. You might watch billions of years of cosmic history unfold in moments. Stars could form, galaxies could collide, and the universe itself could age far beyond the era you once lived in. In theory, if you could somehow survive the extreme environment, you might witness the distant future of the cosmos while falling inward. But eventually, every path inside the black hole leads to the same destination. The singularity? At that point, tidal forces become infinitely strong. Space and time themselves collapse inward. Every atom of your body would be crushed into an unimaginably tiny region. And that seems like the end of the story. But black holes still hold some of the deepest mysteries in modern physics. One of the biggest questions is, what happens to information? In physics, information about particles and their states is supposed to be preserved. But if something falls into a black hole and disappears forever, where does that information go? This puzzle is known as the black hole information paradox. Some theories suggest the information is somehow stored on the surface of the event horizon. Others propose that it slowly leaks out through a process called Hawking radiation, discovered by the physicist Stephen Hawking. According to this idea, black holes are not completely black. Over incredibly long periods of time, they slowly lose energy and eventually evaporate. A stellar black hole could take far longer than the current age of the universe to disappear, but in theory, it will eventually vanish. And when it does, the question remains: what happened to everything that fell inside? This mystery connects gravity, quantum mechanics, and the fundamental structure of reality. Solving it might lead to an entirely new understanding of the universe. So the next time you look up at the night sky, remember that somewhere out there, these invisible giants exist. At the centers of galaxies, including our own Milky Way, supermassive black holes quietly shape the motion of stars and the evolution of entire galaxies. They are not just cosmic monsters, they are laboratories for the most extreme physics in existence. And one day, they might help us unlock the deepest secrets of space, time, and reality itself. If you enjoyed this journey into one of the most extreme places in the universe, make sure to like this video, subscribe to the channel, and turn on the notification bell so you never miss future videos about space, science, and the mysteries of the cosmos. And before you go, I'd love to hear from you. What do you think would really happen inside a black hole? Let me know your thoughts and questions down in the comments. Thanks for watching, and see you in the next one.